Okay, welcome back to Mathematics Kicker After School lesson. Today we'll be proving an ultimate segment theorem, or some people they call it 10 chord theorem, right? Which says that an angle found between a tangent and a chord, which is this angle found between a tangent and a chord, is equal to the angle subtended by the same chord in the alternate segment. Again, it says that the angle found between a tangent and a chord, the chord is equal to the angle subtended by the same chord in the alternate segment, which means this angle is equal to this angle. Then today we'll be proving this theorem. It's a tan chord theorem or alternate segment theorem, right? Okay, I'm gonna show you two different ways of proving this theorem, right? In the next video I'll show you another way, and in this video I'll show you this method, right? For this method we use three theorems proving this theorem, right? We use a theorem of what? Of 10 radii, ne? We use a 10 radii theorem, which says that the tangent is perpendicular to a radius. Again, we use a diameter subtend angle of 90 degrees, or angle in the same circle, right? And the last one, we use angles subtended by the same arc, or angle in the same segment, right? Another theorem of proving this theorem, right? We use three theorems of proving this theorem. Then in the next video I'll show you another method of proving this theorem, right? This question was taken from NSC 2017 November grade 12 paper. Okay, before you do anything in Euclidean geometry, interpret what you have given. As we can see our scenario, it says in the diagram, chords KM, MN, and KN are drawn in the circle with center O. P and Q is the tangent to the circle at N, right? Then we are required to prove the theorem which states M angle NQ is equal to angle K, right? M angle NQ is equal to angle K. You can see, according to our definition of this theorem, we have mentioned earlier that it says that an angle found between a tangent and a chord is equal to the angle subtended by the same chord in the alternate segment, right? Which means this angle is equal to this angle. You are going to prove the alternate segment theorem or the 10 chord theorem, right? Okay, let's prove our theorem. Write RTP. We are required to prove the theorem which states that M angle NQ is equal to angle K, right? Then now, first thing first that you must do, you must construct what? A line that passes through N to O, right? Construct a line that passes through NO, right? N to O, right? This line. Construct this line. Then you do what? You join your line. Then join your line. Then you mark this part as N1 and 2. Come this side, you mark as K1 and K2, right? Then you realize that if a center, you realize that we have what? You have a radius there, and this radius is perpendicular to this tangent, which means we have an angle of what? Of 90 degrees here. And this side, you realize that this thing is a diameter, right? It's a diameter, and a diameter subtend an angle of how much? Of 90 degrees. Then it means that angle what? Angle N1 plus angle N2 equaling to 90 degrees. The reason is a 10 radi, tangent perpendicular to a radius. And again, you have your diameter here. Ne? And this diameter subtend angle of how much? Of 90 degrees. It means that angle K1 plus angle K2 equaling to 90 degrees. Then reason angle is an angle in a semicircle. Ne? Angle in a semicircle, or diameter subtend angle of how much? Of 90 degrees, right? Then, and therefore we can therefore say what angle K1 plus angle K2 is equaling to angle N1 plus angle N2, because they're all equaling to 90 degrees, right? Then let's come here. We have a theorem which says that angles subtended by the same arc, or angles in the same segment, right? Angle the same segment. If we check, this segment subtend angle K1, right? And again subtend angle what? Angle N1, right? Which means K1 is equivalent to angle N1, and this part is equivalent to angle M, right? Which means subtended by this arc, right? And this arc subtend K1 and N1, right? Subtended by this arc. Then we can therefore say angle K1 is equaling to angle N1. Then the reason angles in the same segment, right? Angles in the same segment, right? If angle K1 is equaling to angle N1, and here we have what? K1 plus K2 is equal to N1 plus N2. We can therefore conclude that angle K2 is equaling to angle what? Angle N2, right? Conclude that angle K2 is equal to angle N2. And we normally know that what? Angle K2 is this one, is the same as what? Is the same as K in this one, in this triangle K what? KMN, right? Which means K2 is the same as what? The same as K, ne? Therefore say what? K2 is the same as K, is equaling to an N2. You see N2 here, and N2 here is the same as M angle NQ, right? Is the equal to N2 is equal to M angle N2, right? Then we can therefore say what? M angle NQ, right? Then if we check here, our what? We were required to prove the theorem which says that what? We were required to prove the theorem which says M angle NQ is equaling to K. And if we check our conclusion here, it's angle K is equaling to how much? Angle K is equaling to how much? M angle NQ. Can therefore say what? M angle NQ is equaling to K. It's proven, right? Then we are done. This is how we prove this theorem. There are two ways of proving this theorem. Always remember to provide your reason when proving this theorem.